Our video today is going to go over different types of angles that you will find in geometry and also how to use a protractor to measure them. So here we go. So angles are defined as two rays that have the same vertex or endpoint. Vertex is where points come together, so think of a corner. The rays are drawn as segments as well, they don't have to have the arrows. But when you label it, the vertex must be in the middle of your labeling. You can label with 3 letters or just one, and you can even label the number or the angle with a number as well. So here are some examples of different types of angles that you're going to have to identify with just a drawing. So when you look at angles and you draw them, what you're looking for is you can label them with 3 letters. You can label in just one letter, or you can label with a number. You need to have a symbol, and it's a smaller representation of what it is. The letter B in this case is our vertices, so that has to go in the middle. We can also identify it by an arc, which is what this black line is. And again, when we say it, ABC has to be having B in the middle. We can also say CBA as well. So some of the angles that you're going to get are called right angles. Right angles are 90-degree angles. So if you think where a corner meets a wall, and you have this symbol that comes up as you go through it. So here's an example of what 90-degree angles look like. So acute angles are angles that are less than 90 degrees. So if you see the number in the angle that's less than 90, that's an acute angle. If it's something that's less than a square, kind of a part of a square, that's also an acute angle. We have obtuse angles. Obtuse are greater than 90 but less than 180. So you can see the examples here. And sometimes they're labeled, sometimes they're not, and they're just going to ask you what they are by what they look like. And finally we have a straight angle. A straight angle is a line. Could be a segment too, depending on how you define it, and it's 180 degrees. So a straight line always equals 180 degrees. So when we measure these, it's a matter of where do we put things using the protractor. And this is what a protractor looks like. A couple things about the protractor is, if you notice, there are 2 sets of numbers in here. And that depends on which way your first ray of your angle is drawn and how it's moved in regards to that. And you notice that they both meet up here at 90 degrees because again that is going to be your right angle. Anything in here is going to be acute, anything out here is going to be obtuse. If they're 90 it's right, if it's a straight line it's 180 degrees. So let's look at a couple of these as we go through in explaining how to use a protractor. So once you get into this section you will need to get a protractor from me because sometimes you need to do some actual measurements. Sometimes they're just going to ask you to identify what they're asking you to find in regards to that angle or the angle's measurement. So if you have a ray that is drawn with one of the rays drawn in this direction, you want to make sure that that is starting at 0. So you're going to use the inside numbers as you go around the protractor to 180 degrees. So if we make this second ray, and if they're small enough to where they can't be seen by using the protractor, always extend them, use a ruler or a straight edge. That way you can see what this angle's degree is. So we start here, and again this is always going to be our 0 number, and we're going to move up towards the second ray in there. And that's going to give us our angle measurement of 60 degrees. We put the symbol for degrees up here because it's a part of a circle, and a circle equals 360 degrees as you go through it. So if we put another one up here, we get our ray going off in this direction. So again I'm going to use the inside numbers. If I have it going off in this way and I continue it, actually, let me start over with that. We're going to use, let's see, we'll continue it off as best we can. So we can go here and we measure it using an arc. So again, we're using the inside numbers. So we're past 90, so it's an obtuse angle. So it's past 120 by the middle part. So we would say that this angle has a degree measurement of 125 degrees. Now if we flip this around and we have our ray going in this direction, now I'm going to use the outside numbers and the 0 is going to be still that ray. So if I have a measurement that goes out or a drawing that looks like this, I'm going to go and measure this way as I go from 0 on up. So again, I'm going to use the outside numbers to visualize what the number is. And sometimes you got to kind of guess a little bit, see which one it's closer to. In this case, you could say it's 68 degrees, or you could say it's 69 degrees. And that's kind of a visual of what you're going to use. But again, you could call it an acute angle as well. So one more as we go through this, we're going to start with our ray going off in this direction, and you want to make sure on some protractors they have crosshairs down at the bottom here, so you would see an extra set here, and you always want to make sure that it's straight. So if we draw one here and it comes out, we're looking out here, and again we want to do as best we can, making sure everything's straight. So we would say this one comes out to be about 132. Even if you said 131, you know, with one or two degrees off, you're all right. So again, this is our 0 because this is our first ray, and we're going to measure it off in this direction here and using the outside numbers. So we're going to talk about complementary, supplementary, vertical, and adjacent angles in this section. So complementary angles are the sum of two angles that equal 90 degrees. So we've got to remember what the word sum is calling for. So you need to have two angles. That's the important part here. Complementary angles equal 90 degrees. So it's two angles added up that gives you a 90 degrees. And remember, a 90 degree is a right angle. So if we look at these two angles and we take a 58 degree angle, add it to a 32 degree angle, that's going to equal 90 degrees. So again, we're looking at the sum, which is our addition, to get our 90 degree angle. So when combining two of the angles to find a complementary angle, they would look like this to make a 90 degree angle. So as you think of complementary, complementary starts with a C. If I were to extend that down, that would make a 9, which I can add a 0 to, so I always know that complementary angles equal 90 degrees. Supplementary, again we're using the sum, but this time we're adding to 180 degrees. Again, you're going to need two angles to make this happen as you work through it. So if we look at an example, we're going to take 139, we're going to add it to 41. That again is the sum. So we're adding, and that's going to equal our 180 degrees. So when I combine the angles, they make 180 degrees, which is our straight line. So if I look at the letter S and I continue it through, I end up making an 8. So if I add that, I know that 180 has an 8 in it. That equals our supplementary angles. So that keeps them straight between the two different ones. So vertical angles, these are my kind of the funner ones. These are formed by two intersecting. So intersecting means that they're going to cross. So intersecting, here's their intersection. They also do something interesting as well, and that's going to come from the diagram as we go. So with vertical angles, this is what they look like. And the other thing that they do is if I look at this angle and where I draw out a face, and I draw this angle, and I draw another face, you notice that they are face to face. So they face each other. The other thing that they are is they're congruent. And we'll define congruency here in a second. Well, congruent is that they're the same size and shape. And this is the symbol that we're going to use for congruency. So it's an equal sign, meaning that the same size, and the little squiggly line on top is referring to the shape. So it's set over the equal sign, so everything is the same. They're exactly identical for that. So when we're looking for vertical angles in a drawing like this, what we're looking for is angles that look the same. So if I look at this one, ADG, that also looks the same as over here. So these two would be congruent. The other thing is these two over here are also congruent for the degrees that they may have, or they may just look that way. And that's sometimes that they're looking at it. But again, remember, they face each other for that purpose of being vertical angles. So again, we're looking at two vertical angles. If we write it out and we say angle AEB is congruent to angle, and again your symbols are important, DEC. So angle AEB, is congruent to angle DEB. So adjacents are a little bit more complicated in the sense of this. There's a couple things here. One is they share a common side. They share only one vertice or vertex. And the key point of this one here is they do not overlap. So that means you can't cross over something to get to an adjacent angle. And I'm going to show you a little trick that will help you with that as we go. So when finding adjacent angles, they will actually give you one of the angles that they want you to work off of. So I'm going to give you angle AEB, and they're going to ask you to come up with two adjacent angles. Now the trick for this is this. What you want to do is identify the angle that you're working with, and that's angle AEB. From there you want to take and put two dots on the ends of where the rays are. From here what you're going to do is you're going to go away from the center of that angle, and you're going to stop when you get to the other one. And you're going to go to do the other side and stop when you get to the other ray or a segment that's coming off the letter E. So here's our common vertex, here's our common side, and you've just identified now two adjacent angles for this drawing. So using this diagram we can find vertical angles. We can identify that angle 4 is vertical to angle 7, angle 1 is vertical to angle 5, and angle 6 is vertical to angle 3. We can also do measurements of angles and say that, well, if angle 3 is 40 degrees and angle 1 is 70, I also know that angle 6 is going to be 40 degrees because they're congruent. Angle 5 is 70 degrees because it's also congruent. And if I want to find angle 4 and 7, I would take these two, add them up, and I would subtract from 180. Well, these two angles add up to 110. To find this angle, I would subtract 110 from 180, which would give me 70, which would make this angle 70 as well. So that's how I identify the angles as vertical and their degrees. So parallel lines and transversals are a specific drawing that you can use. Parallel lines are lines that never meet. But the setup is two parallel lines that are intersected by another line. That other line is what's called a transversal. So the setup you see here is what we call a parallel lines with transversal. Line 1 and 2 are parallel. Lines 3 is a transversal. It's the one that splits through or intersects the parallel lines. So the special angles in this part are what we call alternate interior, alternate exterior, and corresponding. For some reason, the corresponding ones are usually the toughest ones to look at. So alternate interior. So alternating meaning we go back and forth from something. Interior means we're going from the inside of something. So we're always inside of, in this case, the parallel lines. So what we look at is when we get the diagram, these are what look like and what are called alternate interiors. We are alternating from this angle to this angle. We're alternating across the transversal, and we're inside the parallel lines as we look at it. Alternate exteriors, okay, alternate, we already know what that is. We're going across the transversal. Exterior meaning we're outside of this, and this is the outside of the parallel lines. So again, this is kind of what they look like. So you have angle 1, it's on this side, we go across and get angle 2, and they're outside of the parallel lines. So they're not inside here, they're more outside at this point. The other type of angle we have in here is called a corresponding angle. A little different. They do not go across anything, so they're not going across a transversal. They're on the same side, but they're either going to be on top of the parallel lines or they're going to be on the bottom of the parallel lines. So looking at the diagram, you can see that angle C and angle A are on the same side of the transversal. They're also on top of the parallels. Angle B and D are on the same side. They're also on top, so they are corresponding angles. Now I can also continue this and say angle E and angle F, they're on the same side, but they're on the bottom of the the parallel lines. So again, that's how corresponding angles differ. So when we look at it, now we can start throwing vertical angles back in here, as we've done in the past. So when you're given this diagram, you're going to be asked to find different angles. Verticals, corresponding, alternate interior, alternate exterior, and also supplementary. So you need to use the diagrams that were given in this section to help you identify those types of angles with this type of drawing.